Hello, good afternoon, everyone. Maybe we give 1 more minute if we are going to have a few more people who will join us. Then we can proceed. Okay. Good afternoon, everyone. Welcome once again to this webinar. It's the second of what we started yesterday, which we themed diving into wealth. Yesterday, we spoke a little bit about well constructions, where we covered aspects on geophysics studies that should be carried out. We covered aspects on borehole components. We covered aspects on some common mistakes that are encountered during borehole constructions or drillings, and talked a little bit about flushing of boreholes, as well as different documentations that we may need to use to ensure that our boreholes are properly drilled. One other aspect was about the supervision, which I think we kind of highlighted a little bit upon. Today we are going to talk a little bit more on the pumping test. We are not going to be exhaustive on what pumping test entails completely, but we are going to talk on some aspects of pumping test that we assume can help us in the field. Again, as I mentioned yesterday, all things being equal, in October, perhaps we should be able to do another session on well borehole rehabilitation, and probably we could develop any other ones if we see that interest is manifested for this. So I am Olivier Camto. I'm talking to you from Cameroon, and I'm working in Okba as a Watson MST. What we are going to cover today is what is a pumping test, and why do we carry out pumping test when we engage with borehole or well drilling. We are going to try to talk a little bit as well as what we need to be able to carry out a pumping test properly. We will try to look at some steps into doing the pumping test, and as well key documentation for the monitoring of pumping tests during the drilling, and also for archiving. What we are expecting to dish out as information today will be to ensure that our teams in MSF are confident if we have to run a pumping test, or if we have to supervise the running of a pumping test by a contractor to whom we may have subcontracted this activity. To also understand what it is, the safe yield, why it's important, the safe yield, and how the safe yield helps with respect to pump sizing before we install the pumps into our borehole, and as well to know how to monitor and supervise the pumping test and the different data we would need to collect for this. Diving into the subject matter, then we would start by pumping test, and I would like to ask, can anyone tell us what he or she thinks is a pumping test for a borehole. You could write in the chat. You could speak up if you'd want to. Paul, you may want to help me in case somebody, since I cannot see the participants. There's some background noise coming from somewhere.
Sounds like someone was in a sports centre. So please go ahead and answer, Olivier, please. Either write it in the chat or just speak out, please. What is a pumping test? To you, what is a pumping test? Something to do with a pump, I guess, but what do you think?
Hi, everyone.
Hi, go ahead.
So pumping test for me is a way to identify the characteristics of the borehole and the aquifer. It could be done through continuous pumping for a certain period of time with registration of how it will affect the water level, the static water level inside the borehole. After that, we can determine the size of the pump based on the safe pumping rates, okay, and the capacity for the aquifer to recover.
Anybody else wants to join in with that or add something else? I think, Olivia, they enjoyed that answer, so go ahead.
Proceed. Yes, please. I'll proceed exactly. And thank you, Adil. I think that is Adil. I know the voice. He's my friend. So thank you very much, Adil. And you've kind of, yes, answered a little bit to the question and even gone a little bit further. But a very short and easy definition for a pumping test is pumping water out of a well or a borehole at a constant or a variable rate, continuously, as Adil mentioned, and very importantly, monitoring the water levels with respect to the different flow rates we are pumping the water out. There are several types of pumping tests which we can encounter. But what we encounter most, especially generally, are the step drawdown test and the constant rate pumping test. In this presentation, we are going to focus mainly only on the variable or step drawdown pump test, and not the constant rate pumping test. Reason being that the constant rate pumping test is a test that, first of all, should more or less be carried out after we have done the and then also someone said something.
Slight cut when you were speaking, Olivier. Speak a little bit slower.
Okay, I was saying we are going to focus here on mainly the step drawdown or the variable rate pumping test. The constant rate pumping test, we will not cover this, mainly because first it has to be done after having done the step drawdown test, but also because it needs to be done over a longer period of time, sometimes going exceeding 24 to 72 hours. And also, yes, exceeding 24 to 72 hours. And with our context where we are, with the security context and stuff, it may be very challenging for our teams to be able to run this kind of a pumping test if we do not have automated data logging devices. So here we are going to focus mainly on the step drawdown pumping test. Then now the next question. Again, it's a little bit similar to what the pumping test is, and Adil started giving some answers to what it is. Why do we do the pumping test? First and foremost, but it's not the only reason, could be to be able to determine the safe yield of the borehole. And by safe yield of the borehole, we are looking at the maximum pumping rate, maximum safe pumping rate we can extract from the borehole over a given period of time to prevent the borehole from eventually drying up or to prevent aquifer damage. Secondly, also, again, as Adil mentioned a while ago, it's to help us inform on the system design. And by the system design, I'm talking here of designing the pump that we may eventually need to install into our borehole, and also well, designing the pump especially, but the pump, it comes with the total dynamic height and these other parameters that have to be estimated before we know what we have to put into the borehole. Then also, it may also give us an idea of what the water quality is when pumping is occurring inside of the borehole. So during the pumping test, we can be measuring some key parameters, especially the electrical conductivity, which could inform us of the potential presence of some of some solids or some salts in the water, and it could inform us if when we may be able to, when we may have this water, or perhaps from what aquifer this water may be coming from, depending on the characteristics of the borehole we may be having. There are many other reasons why we may want to do pumping test. For us, mainly will be the safe yield and the system design. But again, in other exploitations where you may need to assess borehole performance, you may need a pumping test. If you want to estimate aquifer properties like transmissivity and storage and the storativity, for example, you may need also pumping test, and generally the constant rate pumping test, among others. So there's many other reasons why we may want to consider doing a pumping test. But as I mentioned, for us, we would focus a little bit more on the safe yield and the design of the system. Then let's look at the requirements for doing a pumping test. If anyone has done pumping test before, could we give a few? Could we list or say in the chat some items we may require to run a pumping test?
What do you need for a pumping test? He's asking. So either put it in the chat or open your mic and okay. Ben says dip meter in the chat.
Okay.
Anything else you think is required in a pump test? A pump comes up for a pumping test, which is quite good.
Very important, yes.
Stopwatch, water level indicator, pump and generator. Ben wants a clock or timing. Yep. Okay. Coro wants a generator. Let's go with the thing, that's fine. Flow meter, logging sheets. Yeah, logging sheet comes up a couple of times, which is good.
So I would continue from here, and that's very interesting. I was actually even waiting to see if we were going to get the login sheets, because most of the times people will forget that, but it's something that is practically very important, but can be neglected sometimes. So yes, the list, the items I heard listed, we have some of them already in the MSF what do you call it, the MSF catalog, and we can classify them into several classes. The water level measuring equipment, like the dip meter, which we use to measure the water level as the pumping is occurring, and the water level is reducing inside of the borehole. This can be manual, and like what we see in the picture, or we can have automatic data loggers that we can also use if we have sophisticated programs and we have the means. We equally have the flow measuring equipment, which is the flow meter, which again we have in our catalog, but sometimes we do not have the flow meter, and most of the times in the context where we are, we resort to traditional methods, the traditional bucket stopwatch, the traditional bucket and stopwatch method. But there are also other methods which we can use to measure the the flow rate while doing the pump test. Something that is also kind of important, especially when we do not have a flow meter, is valves. We need a valve that is installed at the outlet of the pump for the regulation of the flow, so that's what we use to regulate flows, especially for the variable or the step drawdown pump test. Then, as was mentioned as well, we also have the what do you call the pump, which is definitely very important for the pumping equipment for the pumping test, because this is what is going to be able to draw water from inside of the borehole or the well and send to the surface. And definitely we would need associated to the pump, the power cable, the rising main, the the generator, the discharge hoses, etc., etc. This is an example of a pump which we have inside of our catalog. It's not the only pump that should be used for a pumping test. It's, as I said, it's an example, and whatever whatever case we find ourselves in, we can use this pump or any other pump which we can find. Some important message to put here is to not use solar pumps during pumping test. For one main reason is because solar pumping rates increase over time with the increase of the solar irradiation So it may be difficult, especially if we want to when we want to run a pumping test. If we are doing a constant pumping test with solar pumping, it's practically not going to be very possible, because the irradiation values from early morning towards afternoon will never be the same. So it's almost going to be not possible to manage this. And similarly for the step drawdown test, where, as we'll see in a short while, we'll have to be playing with the different flows. It may be a little bit challenging again with solar pumping. So when running the pumping test, we would advise to not use the solar pumps or to do a pumping test. Then we also have water quality testing tools. I don't think this was mentioned in the list in what people were commenting, Paul, but this is also something that is important. And most at times in our context, we tend to forget about this. And this is mainly what we have here, for example, is the conductivity meter, which can help us measure the conductivity of the water. It can help us measure the total dissolved solids, etc. The idea for this is to give us first a very rough idea of what the water chemistry may be. And when I'm talking of water chemistry, it can give us with high conductivity values may indicate presence of some salts inside of the water, or high TDS, total dissolved solids, may indicate presence of salts in the water, which may not be good, which may indicate that perhaps this water may eventually need treatment and these kinds of things. So it's a very important parameter to try to understand during the phase of construction of developing the borehole, or during the phase of pumping test, to give us the first rough ideas of what the quality of the water may be eventually, before moving on to a lab to do a proper analysis. And last but not the least, again, the data logging sheets, which again is very important. We mentioned the pumping test is we have to be pumping water at a constant, a variable rate, and measuring the water level. So we need this to be able to get all of the information, and it is this information from the water from the water levels and the pumping rates that we would have to exploit later on to try to determine what we can consider to be our safe yield. So we have the data quality sheets. We definitely need to have our pens. We definitely need books, etc., etc. Then how do we run then a pumping test? Before we move forward on how we would run the pumping test, the idea is to talk very briefly on some key aspects which are important in the pumping test. And first would be the yield, which is what amount of water we may be able to take out of the water eventually. And we would, I've already mentioned safe yield and stuff. We would use the safe yield, which accordingly, based on the information we would gather from the borehole, from the pumping test, should be the yield we should aim at using, so as not to overexploit our borehole and avoid problems like clogging, like destruction of the aquifer and so on. And also even avoid the destruction of the pump, because we need, when the pump is installed at a certain level, and if we over pump water, we can go down up to the pump level, and then if we reach the pump level and we start having dry run problems, then it can also bring problems to the pump, and eventually this can lead to shortening the lifespan of the pump. Then we will talk about the static water level, which is the water level when the borehole is at rest level. When you finish doing your drilling and you leave the water to settle, this is like the water level inside the pump before any pumping event. Then associated to the static water level is the dynamic water level or the pumping water level. So as we pump the water, which is definitely what you see this, I don't know if I should do this, which is this area below here. It's associated to the pumping water level. So as the pump is when the pump is actioned and it's working, then the water level drops from the static water level, which is above here, to the dynamic water level, which goes down below here. And this when it comes down to this level at the equilibrium or the maximum pumping rate, we notice this is the total height of water that has to be moved by the pump when the pump is working. So this factor is very important in designing in the design of the pump. And then eventually also what we call the drawdown, which is a difference between the static water level and the dynamic water level. So running the pumping test proper, the first idea would be to first determine what we would call a design yield. And the design yield, there are several methods. Remember, we will be talking here about the variable rate or the step drawdown pumping test only. The design yield here, we can get this by several means. First, we can go by assessing what are the needs of the pumping what are our needs we want to cover. We can assess the population, we can see what is the total water needs of this population, and then from there we can get an idea of how much water they need, and we can then deduce how much we may be able to need, how much water we may want to pump out of the borehole to be able to cover the needs of the population. So this is one method which we can consider using to determine the design yield. Another method which we can use is to run first what we call a dimension test, and we get this figure arbitrarily. We run the dimension test, and then we set it up if it is if it's okay and if it can cover our needs, the design needs that we have run, that we have designed, we defined. We can then decide to use this as a design yield. Or again, generally during flushing, I think yesterday was mentioned, when we are doing the flushing, we have to do the flushing until the water that is being flushed out of the borehole comes to a stable flow. So sometimes we can decide to use the flow that is given by the driller, by those who drilled, and generally was gotten from the flushing. But it's generally not the best. But yeah, sometimes it's also used. Then after having this gotten the design yield, what we need to do now is to set up the different flow rates for the variable rate pump test. Remember, we talked of the variable rate pump test. So when we define the design yield is set, and then we have to ensure we have 4 different rates. Would recommend always 4. That's actually what is recommended. 4 different steps. That's why it's called the step drawdown or the variable rate, so that at each step we have a different flow rate. We pump water and I'm using this flow rate, and then we measure the corresponding drawdowns at different time limits. So we ensure that the different flow rates are set: Cure 1, Cure 2, Cure 3, Cure 4, all based on Q0, which is our design, which was our design yield. It has nothing to do with the safe yield as at yet. It is just an arbitrary design. Sometimes we can take it higher than the design, than what the population needs and stuff like that. So it's really arbitrary, and this is work that has to be done beforehand, 1 day or 2 days, or at least the day before, prior to running the pump test properly. Then once this design yield is once the yield has been set, what we should try to ensure the day before and probably I mentioned a while ago, we're talking about the dimension test the day before. We should try to ensure that the flow rates that we have chosen, we would be able to run the pump test at this maximum flow without having any problem in the borehole. And when I'm talking of problem, I'm talking mainly of having a dry, of running the risk of having a dry run situation. So it will be ideal on the day before, first and foremost, if we do not have a flow meter, we would have to use our valves that I mentioned, the valves a while ago. We would have to use our valves to be able to, we would have to run a test the day before to try to set up valve should our Q1, our Q3, and our Q4. We should go, we would have our valves and then valve, and then based on calculated Q1, Q2, Q, we then open the valves and then we try to measure the flow rates, and we set the position indicate so that the next day during the pumping test proper, we are not manipulating the valve very much, because as soon as the pump is started, don't have the only modifications should be to progressively increase the flow rates of the pump. So that is one step that is very, after having set up Q1, Q2, Q3, Q4, we try to indicate the different positions on the valves before. Then once that, so we should run a complete, we should run it again as well at Q4, which is the maximum, the pumping rate during the pump test. We should run the test again at Q4. Total duration, at least duration of of the variable rate pumping is so that during this step, if the pump is 1 hour, 1 hour 30 minutes, then the flow rate should the drawdown, should at the level that of the pump limit, so that we avoid dry run scenario. So
Olivier?
generally, when we if we noticed from the
1 second, Olivier, please.
and a lot, I'll go back to it.
Olivier, 1 second, please.
From this diagram, this is an example of a step drawdown pump, and you'd see when you start the drawdown
Olivier,
increases.
1 second, please. Olivier?
Yes.
1 second, please. You're breaking up quite badly. Maybe if you turn your camera off, you can get a good enough. Your voice is breaking. So if you can just turn your camera off, you might get a bit more bandwidth. We were losing you at the end of the last slide. Okay, thank you very much.
Okay, can I turn it off here?
See if that makes it any better.
Okay, you let me know. Thank you.
Go ahead.
Trying to find my screen now.
If people have questions on the last slide that weren't completed, feel free just to write them down or put them in the chat or save them till the end of the presentation. Go ahead, please, Olivier.
Sorry, can you see my screen? I'm trying to find.
I can see your screen. Your microphone is on, your camera is off. So all you have to do is take that down and you'll be on your presentation.
Are you seeing the presentation now?
I'm seeing the presentation plus that's it. Now go ahead.
Come on. So I was explaining a while ago, during the pumping test, during the step, there is the characteristic drawdown curve should something similar to this, where there is a very sharp pumping event and it gradually stabilizes at the end of the pumping event. I have situations like this one, for example, yet properly, so there is an issue with this particular flow rate, and generally it's not recommended to restart and restart. So the best when you're running your pumping test, the step drawdown pump, should generally ensure when it on curve, more or less it follows this aspect. Then to the front. Okay. Again, because I am able to move on, yes. On, yes. Voila. So that now for each of the steps we are 90 minutes. 90 minutes. Why? Because it's and some this is we use and not we cannot start for
Olivier, sorry to say you've gone again. Your voice has gone again. Olivier? Olivier? Sorry about this slight technical problem.
I think he's having some issues.
I think he's having some issues, yes. Let's see how he can restart. Yeah. Okay, well, we have a, hold on. Meanwhile, we have a question on the chat. How do you find Q0 quickly? Is there an experimental in reality? It requires quite some data to estimate the demand, especially in urban and suburban areas where we have various water demand categories. Yes, you're correct. It's an estimate initially for your requirement of how much water you actually need. So yes, and you can reassess the estimate afterwards to make sure that to adjust your estimate to see this. But yes, it's an estimate of demand. Right, I haven't got Olivier yet. I'm just trying to find him.
He's around. He's around. He's coming.
If you,
hello.
hello, Olivier. Do you want me
Yes.
to do the presentation from my side and you talk over the slide, or do you want to carry on?
Go ahead. Go ahead. I don't know what. Sorry, my connections from here is not always the best. Yes, Paul, please, you can proceed. You can proceed.
Let me see if I can get the presentation in the right place. Is this the correct one?
It has the presentation. Yes, the slide before that.
Hold on.
So
Let me just get
slide before that.
So which slide would you like? 17, no. Can you see the presentation?
Okay. Yes.
14, please. 14.
14. Okay,
the slide
thank you
before
very
that,
much.
Paul. Some slides before that.
Okay, number 14 you have.
Yes, number 14.
Okay.
Yes, thank you. So yes, I was saying we have to ensure we should do the each of the steps. We are recommending each of the steps for 90 minutes, but if you can do it for more, it is going to be so that we get as much data possible, which will help with the interpretation of with the interpretation for the step draw. Next.
Which slide?
Next one.
Andre, which slide does he want?
15.
15.
The next.
Okay. Okay, this is the dimension pump test I have mentioned a little bit again, a little bit before. Test here, the idea is before the pumping test, as I regulate our valves to ensure that set to each of the positions that will give us the required flows which we had set and we to have during the pump test with the force which is maximum rate for the pumping test. We should run that for at least 90 minutes. 90 minutes is the time we have defined one step to ensure that during the event we do not exceed the pump level inside of, so we avoid we dry. I think I already spoke about this. Next slide, Paul. Then the step drawdown pump test, yes. Again, so once we have gathered all of the data we need, we have calculated our Q1, our Q2, our Q3, Q4. We have set the time we need for our pump test, 90 minutes. It could be less, but no big deal. How do we run the pump test? We should ensure that we start from the smallest flow, which is Q1, and then progressively go to the biggest flow. I've seen in situations where the inverse, they do the reverse, and that is generally not recommended. So we should always try to ensure that the flows we start from the smallest to the biggest. Also, the ratios which we had for the definitions of Q1, Q2, Q3, this is also important. So that also we should try as much as possible to respect that which we are which is it's kind of evenly during the pumping to record values immediately at the start of each event important. So at it is gathered to record recommending generally is we should down level every third.
Olivier, sorry, your voice has gone again. We'll see if Olivier can connect again. Olivier, go ahead. Are you still there?
Yes, so I was saying when at the start of each pumping event, there is first of all a turbulent flow that occurs. So we should try to gather as much information concerning the drawdown at this particular point. So we ask when we start running our pump test for the first 5 minutes, we should record the drawdown values every 30 seconds. Then the next 5 minutes, we should record the drawdown every 1 minute. And then eventually the rest of the pumping event, we should record the drawdown every 5 minutes. This is going to be very fastidious for some people because it's going to need them to constantly record values. And when you ask this to some people, it becomes tricky and they don't like to do this. We are insisting, we are really trying to stress on this aspect that this is very important to gather these values, because the more values we have, the more reliable we can interpret the results of the pump test. In some situations, we've seen where in one step of the pump test, people record 4 values, and they use these 4 values they use these 4 values for their interpretation. This is generally not recommended. Then after having finished the pump test at the end of the 6 hours, or it could be 8 or it could be 4, depending on the step or on the time you use for your pump test, we should eventually try to leave the pumping the water level and follow the recovery until the water level the water level inside the borehole goes back up to the static water level. In many instances as well, we have seen where while we MSF are drafting our contracts, we draft our contract and we include in the contract, you should do a pumping test with a recovery of 1 hour, or maybe with a recovery of 2 hours, as though this is the only time for recovery. This is generally not a good practice, and we would always encourage, where possible, to allow the recovery to take the time it is supposed to take, to ensure that after a pumping event, the water level can rise back up to the static water level before the next pumping event. If this is not a possibility, if this is not possible, then this can inform us of the kind of aquifer from which we are tapping water, and it tells us that if the more we pump water, the pumping rate is kind of higher than the rate at which the aquifer feeds water back into the borehole. So it can start giving us clues as to whether or not our borehole will be efficient or not. We are not going to get into details of the recovery test because it helps with aquifer properties, with the transmissivity, with the storativity, which is the rate at which the aquifer stores water, or the rate at which it feeds water back into the borehole. That's not going to be the object. But first of all, just getting an idea of the recovery can already start telling us whether or not our borehole may be a borehole that can be eventually used over a long period when we are exploiting it. Next slide, please. Thank you. So after having carried out all of the pump tests, or while carrying out the pump test, as I mentioned a while ago, it's very important to collect the data, and we have these sheets which help us to collect the drawdown level in the field. Generally, we can get this information and we can plot it directly on graph papers in the field for those who are experienced and who are comfortable with it. We can actually do the pump test in the field and finalize our pump test and even get our safe yield while on the field. But if it's not going to be the case, then we strongly recommend to record the values as we have requested, the drawdown values for each pump rate after at the prescribed times which are given here, every 30 seconds, then 1 minute, then 5 minutes, and eventually for the recovery. And once you have all of this, you can then share with your HQ or with your HQ referent or your HQ focal person to assist you with the analysis of the pump test. Next slide, please. Yeah, we have some examples. We have some examples of some pumping test results that were carried out for a particular borehole. These results are for the same borehole. One was done. These were done by two different service providers, and you see the shape of their graphs of these step analysis graphs that they have plotted here. I will not get into the details of the borehole performances, but when you look at the shapes of these curves, you understand that already there is an issue because they are not similar. If we look first of all at, okay, Paul, you are moving something. If we look first of all at the one mentioned November 2023, you'd see from this top graph, you'd see the flow rate here. The flow rate here is 2. The flow rate here is it's about 2 meters cube per hour and a little bit above, about 3.5 meter cube per hour. But if you follow it below, you see that the drawdowns at different flow rates seem to be similar. So it's a little bit tricky. On this other one, the different flow rates which were used for the pumping were very close together, and as such, also the interpretation becomes kind of challenging. On the third one for March 2025, this is the same. This is for the same borehole, and generally for all of the pump tests which we carry out, this borehole, the curve which you have below, the borehole performance curve, should generally always, when we do the step drawdown test, should always try to have this shape. If your curve does not have this shape, because it represents progressive pumping, progressive in sense of increase in the flow rate, then that causes a progressive increase in the drawdown of the borehole up to a level where first there is the pumping that is lower, the pumping rate is lower than the recharge rate. so the drawdown is relatively little. But the further you go, the pumping rate starts getting smaller. Sorry, starts getting higher than the recharge rate. And as such, when it starts getting higher than the recharge rate, the drawdown drops drastically, because we are pumping more than what the borehole is, the aquifer is being able to fill into the borehole. And there we start, we generally get this information from these curves when we start noticing these sharp trends these sharp dropping trends. So generally, that is the idea behind why we ask to define Q1, Q2, Q3, Q4 as we saw previously, and then when we follow the pumping rate and we ensure that the drawdown values are collected accordingly, we should be able to plot this curve as we see here, which is a curve of the flow versus the water level. Then a very easy method to assume what may be the safe yield, the safe pumping rate of the borehole will be to first, from the area where the borehole, where there is more recharge than pumping, we kind of draw the best fit straight line curve that will touch the maximum points on this portion of the characteristic of the borehole performance curve. And then on the other hand, where there is a sharp drawdown, where there is more pumping compared to borehole refill, we draw another straight line curve. And then generally we can use the intersection of these two curves. This could be, this is what we can consider to be our optimal pumping rate. And from this pumping rate, if we drop down to where the curve is, it gives us an idea of what the associated drawdown for this pumping rate may be. So it gives us an idea of what the dynamic water level inside the borehole could be. But given that this is a kind of approximative method, it is generally recommended that after having determined the optimal pumping rate, we should apply more or less a safety factor, which is which can go from 80 to 90% sometimes, depending on the person and on the context, so as to account for perhaps some possible errors that may have filtered in during the pumping. Maybe some values were not collected. Maybe there was a very slight problem with the pump, with the COVID, adjusting the valves and stuff. And then this is what the Q safe here, it should be the safe yield, the safe pumping rate, which after the step drawdown pump test, we can kind of consider as our exploitation yield of this borehole. Generally, if we have to do the constant rate pump test, which is now help us more with the characteristics of the aquifer, then we should use this safe yield developed now from the step drawdown pump as the input of flow rate of the constant pumping test now, and then which will be over a 24-hour period to be able to characterize a little bit more what is, but this goes beyond the scope of this. Next slide, please. So that's the procedure that we should use generally for all of the pumping tests. One thing I did not mention, and which is of utmost importance, is the fact that once we start our step drawdown pump test and eventually the constant rate pump test, at time, should we stop the pump? Stop at any given point in time for any given reason, then should have to stop this. So we start test. If we the pumping is 6 hours, we should ensure that we pump running for 6 hours continuous interference. If there is any interference, we have, then when we stop, we should generally we should generate a hole so that the static water level rises to the static water level before eventually start any pumping event again. Generally, we would recommend 12 to 24 hours. So that is really, so why I'm saying this is to ensure that we want to run the pump test, we should ensure that our pump is in good shape. Everything we need is in good shape. I'll give an example of a pump test which we actually this one which and we had to restart 3 times because and once the generator fails, everything has to start afresh. The pump test, we have 2 main levels of we have the responsibilities for the driller, or the person who drilled the ball. When I'm calling the driller, I'm talking the person who is running the pump test. The driller, the person who drilled, it could be someone else, so we got it to someone. And then it could as well be MSF. In situations, Paul, you will have to press, you will have to your mouse to right. And in any of the situations, then we have to ensure that MSF, we are ensuring, even if it's MS, the driller or anyone else, that the flow rates that we that the drawdown is is properly measured to ensure that the times that request that all of this is important. But we have to ensure that flow rates are set, the timing, the time, and then the equipment that has to be used is the proper that is being used. Don't know if you lost me or if we can continue. If we continue the next slide.
We lost you a little bit, but we continue.
Thank
Resources.
you. Resources. So now with after all of this, therefore, as to what we saw yesterday, first agreements is the MS is the standard contract. OGBA pumping test specifications which we have developed, which we encourage all of our try to all something's happening.
Go ahead. Sorry.
Okay. So we have the technical specifications which and in the technical specifications for the drilling, which is like detailing a little bit what we just want our teams to use. The money which we have for it. And as well, those are the 3 main sheets which to the 3 main which have test. So I think what we try to push therefore in this training webinar, next slide, Paul, was that we are able to properly define define the different pumping we are going to use during the we should be able to define our we need collate all of the data necessary beforehand and before it is us MSF which we should ensure that this is understood by the pumping team. If it is not us, we should ensure that this is understood by the service provider with this. And it's only with that we have and view this what use a pump. Design of the pump is not part of this, it's not part of we can run, but the idea able to come up with the safe yield. And for this to be able to be able to happen, we should ensure that the safe yield, the time, the flow rates which we have, the equipment that good authority, and then when we have all of together with the information from was drilled yesterday, and collate this information, and then we can store in our MSF future references, but also we always recommend to hand this over to the because when we MSF are not around, then they can use this information in the future to try to understand the characteristic of the borehole that was drilled by us, and to see what can be done if they need to intervene on this borehole. Thank you. Sorry for my bad connection, and I think which we have.
Okay. Yeah. Thank you very much, Olivier, for stuttering through this. Unfortunate that we missed quite a lot of what you said in the last few slides. But I'll stop sharing now, and maybe people want to put some questions in the chat so I can have a little idea of what's going on. Olivier, can you read the chat, or do you want me to read out?
I'm going through. Okay.
The first question is how to find Q0 quickly. Is there any experimental method? Does it require quite some data to estimate the demand? So do you know a shortcut to try and find a good Q0?
Yes, I gave two shortcuts in what we would ask you. If your shortcuts that are different from what we would not recommend this. They need to have some which we have. And
Oh, sorry, your voice has gone
it
again.
becomes kind of, yeah, I'm saying not from the needs we intend, then it becomes tricky to define quickly what Q0 should be. So we would generally recommend that we should start from what Q0 should be. Sometimes we may find a Q0 that is very small to what the borehole can produce. That is fine. But for that instance, we are looking for that will be able to give us the amount of water we need to respond to our needs. If there is increases, if there are increases, then we can consider doing the pump test again, Q0, and then we define it, and then we run the pump test. It's what we should really know, that generally when we run, we should not run them only at one period and then we leave that as final. If it's possible to pump test even in the during season variations, that will be very helpful, because in the rainy seasons we may have an aquifer, because there is more recharge into the aquifers, have the possibility to exploit more water from inside the borehole compared to the dry season. So if we take the rainy season, for example, if we take the rainy season safe yield or the rainy season pumping rate that we obtained and try to use in the dry season, it can falter, it can the results for this borehole. So it's generally also important and advised where rainy season you can and we can run a pump test. In the dry season we can run the pump test, and then over time and over the years we can assess and see how the borehole is functioning with what we are extracting. To answer the first question, a different way to find Q0, not very much recommended. Would really ask to use either intent or as a quick start, use what the driller generally gives as the driller's yield. Then next question, should mainly be responsible for pump test driller or different? Okay, getting cut here. Who is responsible for the test? I'm not very sure of what you mean by responsibility, but again, I said, who can run the pump test? We can do the pump. We have another contractor, whosoever can do the pump test. If we MSF need to ensure is that these people required material to do this, and they understand the technical specifications to run the pumping test. That is fine. Then if we do not use these people, and if we are confident and if we will have the material, then we can run the pumping test. At that point, we are the ones to ensure that the pump test is run according to the specifications which we have. In whatever case, our responsibility as MSF ensure that the row is set properly, and then eventually Q1, Q3, Q4 are defined properly. And the drawdowns are measured accordingly as defined on the monitoring sheet which we have, and then all of this information we collect them and then we can analyze them. If I've not answered to your convenience, please you kind of let us know and let me know. Then I think the next question, is it advised to conduct pumping test periodically, mainly in the area of min? Okay, I think these are two questions you're asking here. If it's advised to conduct periodically, it will be advised if you can do that. In many boreholes, yes. It will give you an idea of how boreholes are interconnected. If you can drill 3 boreholes inside in the same aquifer, and then exploit them, you have to ensure that the pumping rate from borehole does not drastically affect B. Honestly, this is actually going to start. If we have to delve into this subject matter, it's going to be a different subject matter, because design holes is a completely different, but it has to take into and to define more or less the number of boreholes or the quantity of boreholes that we have to put in inside the field. If we are afresh, this is something that we consider very beforehand, before even going into. But if we go somewhere where this already exists, yes, it's very important to what the pumping may have on the other borehole, and then we'll use it's with this period that it's with this information we can try to find a different what they call pump the different exploitation is which we share for this box which we are considering. Then the next question is, needs any extra to be done to increase it on the same side? So you be able, can you please, this is Mozambique, I think, is clearly it's smaller than could you be here with this? Paul, could we please unmute Mozambique loco so that I think it's Isabel, no? Can explain a little bit better her question.
What I understand of Isabel, that I don't know if she can unmute, is that if you do the pumping test and you find that the borehole doesn't have enough yield, is there something enough yield for your needs? Is there something you can do to increase the yield? Don't know if I got it right, Isabel. Yeah. Yeah, so that was the question, Olivia, maybe. So is there something you can do once you've done the test, you don't have enough water, to increase the yield that this borehole gives you?
Okay, to increase the yield of the borehole, if the borehole is already drilled and you're talking of increasing the yield, it's a little bit challenging. It's a little bit challenging. In some instances, if we have a very big diameter borehole, we can consider drilling deeper again. But then this is only if we are, I would say, confident and maybe informed from geophysics surveys that perhaps there may be another aquifer which is below where we find ourselves. But if we are in a particular setup, we are in a borehole of 10 meters deep or 60 meters deep, for example, we have a pumping a savior that of this borehole of 2 meters cubed per hour, I'm afraid it's almost not possible to increase the yield of this borehole again. I don't think it's going to be possible. The only solution in this case may be to consider drilling another, looking for another area and drilling another borehole, but it may not be very possible. Thank you. And I think that's all of the questions, except anyone has any other question. I am really, really sorry for my bad internet. Today seems to be a very bad day, but voila.
Well, you can remind them that those who speak French can go to next week's presentations, where hopefully we'll have a much better connection.
Inshallah. Yes, so exactly next week we have the French version of this. I think it's on Wednesday and Thursday again. So those who would be interested or who may need any other further clarifications can also attend this one. Nonetheless, we have the emails that have been, we have our emails. So if you have any other doubts, please don't hesitate to ask. And in whatever situation, please, if you have drilling to do, you have your Watson focal points for your missions, please try to associate them as early as possible, discuss with them, so that we try to follow the procedures as much as possible. Recently, in one of our projects, not long ago, a borehole was drilled, and before we could even run the pump test, the borehole had collapsed. That was in less than 1 week. The pump could not get into this borehole. So there's a lot of things that have to be, the specifications which we give are very important and very vital that we should try to respect.
Yes, and although I think we put the message across that drilling boreholes is quite a technical thing, and please talk to your technical referent or your MST about doing your boreholes. It's not just drilling a hole and walking away from it. As Olivia pointed, there's lots of niche bits of information you need and lots of technical information and things. So thank you very much, Olivier, and thank you for your perseverance going through this webinar. I hope on next week everything will be a bit better and we'll get a better connection. Thank you very much. Any last points from anybody before we go? Okay. Thank you very much for your attendance and see you next week.
Thank you. Bye-bye.